All right, so guys, I'm recording this now. And I'm going to do a refresher about the Pythagorean theorem, just to a squared plus b squared equals c squared. It really doesn't matter what you label as a or b. So, you know, I can label that a and that b, and then I would square the 3 and I would square the 4, and then I'm trying to find out c squared. And so from that, you would just go through and solve. If in the process of solving you end up with a radical that does not simplify to a whole number, so for example, let's say you had the radical 13, you would just leave the answer as 13, radical 13. All right, so that is that. This is the rotation. So this applying the rule, this is just saying that you're going to the left 2 and you're going down 5. And then here, the whole point is graphing it, and since it's in slope-intercept form, you just have to go to this represents the intercept, and I'm hoping that y'all are like, yes, Miss Beck, we totally know this. And when I say intercept, I mean y-intercept, and so I would go here to -3, 1, 2, 3, I'd put my dot, and then I just start counting. 2 over 1, so I count up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And then after I get me enough dots that I can draw a line, and I'm drawing this free-handed, and no, I'm not an artist. I wish I was, because these would look so much better if I was. Then that's what we get. And then I want you to tell me what you notice. So I did see where on the Desmos activity that I was getting I was seeing a lot of good descriptions of what's going on with those lines as far as trying to rotate or reflect or translate.
Miss Beck.
All right, so I'm starting the recording again, and this time I'm going to put some definitions up here. Whoops. So, definition, translation. So it is a rigid motion, transformation that moves every point of the shape the same distance and the same direction. All right, so a property associated with translation. I want to do this. All right, so that's our property that's associated with it, the parallel lines, and I saw a number of you had written that. Next definition and property I want to type out here is a rotation. It also is a rigid motion, And when I say rigid, it just means it does not change the original shape. The original shape stays the same. All right, so definition of rotation. It's a rigid motion that moves points in the same direction along a circular arc. So it's kind of like you're circling around concentric circles. That just means they have a shared center and angle.
I have a question. So for homework, do we just do like the delta math thing and the ready set go?
Yes. That is correct. So the Delta Math is separate. That you don't upload. You just do that in Delta Math, and then with the Ready Set Go, you upload that.
Okay, so can we do it later because like
I paused our video for a second. Let me type in here the property of oh, okay. So the property associated with the rotation is that the segments form twin. So when you're doing a rotation, this will come back handy to know about rotations whenever you start studying circles, which that'll be mainly a Math 3 topic, but it involves rotating around in arcs and being able to recognize congruent radii. All right, last definition. Let's see, where am I at time-wise? Is, to keep this consistent, reflection. Whoops, just kidding. Reflection is a rigid motion that moves points across a specified line of reflection. Image. All right, and the property associated with reflection is that the line of reflection is the perpendicular bisector of each line. All right. So the property of a reflection is that it moves along that perpendicular bisector of that line of reflection. These are the definitions that so I'll add an addendum to the lesson today, since I didn't put this into the slides. And if I did, so what I figured out was that whenever I update the slides, it does not get updated in your assignment, and that kind of annoys me. Because it should, because of the link. It's just a common link.